Hello guys, my name is Subham and today in this video we are going to see a very interesting concept of material science, that is what is yield point phenomenon. This yield point phenomenon generally occurs in low carbon steel or mild carbon steel, and you can see from the stress strain graph of low carbon steel that two yield points are generated, one upper yield point and one lower value of yield point. So why does this happens? This is only termed as yield point phenomenon. But this does not happen in medium and high carbon steel. We will see later why does it not happen. And what is steel? Steel is an alloy of iron and carbon atoms, in which iron atoms form voids between them, and the carbon atoms occupy those voids, and the size of voids are smaller as compared to the size of carbon atoms. Due to that, there is a stress that is generated in this region, and iron atoms try to compress this carbon atom, and due to that we get compressive strain field. So this carbon atom always has a tendency to come out of these voids and occupy some lower stress region. So you can see over here. Coming to this, you must have studied about edge dislocation. Edge, or there are two types of line dislocations: edge dislocation and screw dislocation. So here I have taken the example of edge dislocation. In this, the dislocation movement happens with the formation of an extra half plane, and it keeps on moving further. You must have studied about caterpillar action. So through that, this extra half plane keeps on moving ahead, and this dislocation movement faces a hurdle over here, and it meets with quadrille atmosphere. So that's why the yield strength of the material suddenly increases and reaches the upper yield point. And as soon as this dislocation line moves ahead of this quadrille atmosphere, we get to see a lower yield point. The yield value suddenly drops, and so we get to see only this lower yield point. And as the dislocation line keeps on moving, it faces very small regions of quadrille atmosphere or carbon atoms ahead also. So due to that, you can see that here is a zigzag pattern which is made, and the stress value keeps on oscillating in this region in a very small range. So this is all about yield point phenomenon in low carbon steel. Now we are going to see that why does this yield point phenomenon does not occur in medium or high carbon steel. So this does not happen in medium and high carbon steel because there are sufficient number of carbon atoms to keep on forming the quadrille atmospheres, and due to that we get to see only a single value of yield point. So this is why we do not get to see these upper and lower yield points in case of medium or high carbon steel. And how can you distinguish between different types of carbon steels, low, medium and high? By their percentage values. If the carbon percentage is less than 0.3%, that is termed as low carbon steel. Similarly, these are the values, and 2.14% till 2.14% we get steel. After that we get to see cast iron. After 6.7 we get this graphite. So these are the percentages of carbon that are present in steel. And now talking about this term, what is strain aging? So suppose that if I apply some stress on any object. So if I suddenly release that stress, and if the object is undergoing any plastic deformation, then that object will then this stress value will suddenly drop to 0, but there will be a permanent deformation which will be formed in that material. And when you again try to apply stress in the same direction, it will again the stress value will again increase following this path, and we will get to see a higher value of yield strength, but that yield point will only be single. Why? Because this quadral atmosphere, after this dislocation movement has occurred, this quadral atmosphere, the carbon atoms which are present in this quadral atmosphere, this splits, and it occupies the voids. So the quadral atmosphere vanishes over here, it disappears, and due to that we only get to see a single yield point in case of strain hardening. But in case of strain aging, we again get to see both upper and lower yield points. Suppose that if we keep the same steel sample for 30 to 40 days, then the carbon atoms from the voids will again come and form a quadral atmosphere. Suppose that a dislocation line is here, so quadral atmosphere will be formed over here, and it will again create a hurdle for dislocation line, and due to which we will get to see yield point phenomena again. So this is termed as strain aging, and the time period of that 30 to 40 days is termed as strain aging time. So I hope that you have understood the concept, and if you have any doubt, you can comment below in the comment section. And thank you everyone for watching this video till the end, and please subscribe the channel.